take a look at diacetyl, one of the most important flavours you can find in beer. It's sometimes a good flavour, it's sometimes a bad flavour. Now the chemical which gives us the diacetyl flavour goes by several names. Many people simply call it diacetyl. The International Union of Pure and Applied Chemistry, or IUPAC, says it should be called biacetyl. Its systematic name is 2,3-butane-dione. The flavour it gives to beer is a butter-like flavour. Now butter smells of diacetyl because in traditionally made butter, the bacteria which grow in the butter produce diacetyl itself. But in other cultures where they don't use so much dairy products, for example in Asia, they'll describe it as the smell of spoiled rice because bacteria growing in rice produce diacetyl and give that characteristic smell to the rice which has just been left too long in the pot. When we're making beer, diacetyl is produced in two different ways. All fermentations have diacetyl associated with them. Not because the yeast produces it directly, they don't, but they produce a precursor, a compound which breaks down to form diacetyl in beer. That precursor is called alpha-acetolactic acid. All yeast produce it, and when the compound is in beer, it then breaks down very slowly, sometimes over several days, to give you diacetyl. Now in a well-run fermentation, the yeast then removes the diacetyl and gets rid of it, giving you a very low level in beer, often a level that you cannot taste. But when there's a problem, for example, the yeast flocculates out too early, or they produce too much precursor during the fermentation, then you get too high a level of diacetyl in the beer. Now the other source of diacetyl in beer is contaminant bacteria. These are the lactic acid bacteria, Lactobacillus and Pediococcus. Those produce diacetyl when they're growing. Of course, in a well-made beer, in a clean brewery, we should have no Lactobacillus and Pediococcus. So these faults tell us we have a problem with the hygiene in our brewery. When you analyse beer chemically, it's possible to tell whether the diacetyl has come from poor fermentation management or has come from microbiological contamination. Using a gas chromatograph, you can measure both diacetyl and a closely related compound called pentane-dione. When the diacetyl has come from yeast, you'll have both compounds present in approximately equal concentrations. When the diacetyl has come from contaminant bacteria, you'll find only diacetyl and no pentane-dione. Now for some beer styles, for example traditional Czech Pilsners, some diacetyl is important to the flavour character of the beer. The same holds true for some types of ales, for example Irish ales, and also some types of stout. You want diacetyl to add body and creaminess to the beer. But for many modern lagers and modern craft ales, diacetyl is a flavour we don't want to have there. It's regarded as an off flavour. Now when you're trying to make a beer that has very low levels of diacetyl, no detectable buttery flavour, we're looking to target less than 10 micrograms per litre. But if we want to have a rich buttery diacetyl character, such as in a Czech Pilsner, we may target 80 to 100 micrograms per litre or parts per billion. To pick up diacetyl, there's two ways. First of all, we can smell the beer with a short sniff, and you'll get that buttery or yogurt type character. But the other way is in the mouthfeel. Taking the sample into your mouth, you'll find a slickness or oiliness to the beer because of the diacetyl adding to the body. Slightly different mouthfeel due to the presence of diacetyl. Now diacetyl often occurs when it's arising as a fault together with other compounds. For example, lactic acid will be produced by lactic acid bacteria together with the diacetyl. You can also have diacetyl formed as a result of the yeast being damaged by butyric acid formed in the brewhouse. And when that happens, the diacetyl remains in the beer because the yeast has been damaged by the butyric acid. Those two flavours together, the combination of diacetyl and butyric acid, gives a very unpleasant, baby sick character. This flavour, when present in beer, can be addressed by diluting beer with high diacetyl with beer of a lower diacetyl content. So it is possible to blend the flavour away. But if the flavour's there because of microbiological contamination, that can be a bad thing to do, because you'll simply spread the contamination. If it's caused by contamination, you have to deal with the source and clean the brewery up. If it's caused by poor fermentation management, you have to address the important aspects of yeast management and fermentation control. One of the most important flavours in beer, and one of the ones to focus on in terms of being able to detect it and identify it with confidence. In terms of confusions, people are more likely to confuse it with butyric acid, because that's also found in butter, or perhaps a caramel type character from specialty malts. But confusions are uncommon for this compound. Mostly once people are trained to recognise it, they do so with a high degree of accuracy and repeatability.